Hello. Welcome to the Swarms 8.3.0 workshop. This is the latest updates of Swarms. We're going to be going over some of the latest updates and the latest improvements and things of that nature. So welcome to the workshop. We're going to get set up just about now. All right. Yeah, so this is the Swarms workshop. A little bit of how the workshop usually works is I'm going to go over all the updates, and then I'll show you the code. We'll run the code, and then we could have a Q&A, or if you have any questions, you can let us know. And yeah, so that's generally like the format. So to first answer, if you're new to Swarms, or if you'd like to learn more about what we do, our mission at Swarms is to essentially build the agent economy by building production-grade agent infrastructure tools for startups and enterprises to use to build agentic applications. Our flagship framework is in Python, and we recently released our Rust framework, which is basically like a one-to-one translation of the flagship Python framework. So yeah, if you'd like to learn more, you can go to swarms.ai, and you can learn more there. So yeah, that's a little bit more about us. And so this is kind of like a general overview of the changelog. So we added a couple of new features. We added the batch grid workflow, which is a new multi-agent architecture. We also added in multi-agent execution utilities, which basically enables you to run agents in parallel using UV Loop. We'll be showcasing demos on those features in a couple of minutes here. We also have a series of improvements, such as improving the hierarchical swarm with streaming callbacks. We also radically simplified the majority voting architecture. We also improved our MCP infrastructure by migrating from SSE to streamable HTTP, which is a new, essentially like migration in MCP. They basically stopped SSE. And we also have a vast array of new documentation and examples. And for example, like multi-MCP implementation, you could execute multiple MCP. You can implement multiple MCP servers into your agents now. We also added in like some custom demos, like GeoGuessr agent, which is basically like if you give it an image, it'll tell you exactly where the image is. Yeah, so you could essentially like have an agent know exactly where it is that an image is, which is super incredible. We have Firecrawl, which basically enables your agents to scrape the web. And then we have the Nano Banana agent examples. So Nano Banana is an agent that basically like it can generate images, or it can edit images as well. And yeah, so let's see if we have any questions. We're going to get into the code examples pretty soon here. So all right, let's get into the code examples. All right, so to get started, you basically pip3 install dash capital U swarms. This is how you update swarms. Or you could also use UV. So you could do UV pip install swarms, which I'm not going to do. But if you use UV a lot, you probably should do it. Yeah, that's how you essentially get the latest update. If you wanted to get it exactly, you could do pip3 install dash u swarms equal 3.0 like that. Pip3 install dash capital U swarms equal 8.30. So that's what you could do if you wanted to get the exact update. So yeah. All right, now, so into the batch grid workflows. So this is a new multi-agents architecture that essentially enables you to execute multiple tasks at the same time with different agents. So basically, you have n number of tasks, and then if you have, you can give it a list of agents, and then there's multiple tasks that the agents are going to do, and you can give them the same agents. You can get multiple agents, and you can customize it in like a grid-based model. So I'll show you how that works. Gonna open up our cursor instance here. We're going to zoom in, and we're going to get that away. So I'm gonna make that smaller. Yeah. So this is the first example. We're importing from swarms import agents, from swarms dot structs dot batch grid workflow import batch grid workflow, and we have these agents here. So yeah, these are just simple agents. They have a name, this description, model name, temperature, max loops, dynamic context window, and etc. And then the workflow, batch grid workflow here, we just essentially initialize it and we give it the list of agents. We can also give it a name. So we can give it a name. And if you give it a name, it's actually very useful for when you wanted to orchestrate multiple of these or multiple multi-agent structures at the same time. So yeah, that's very, very useful. And yeah, so you could also give it an output type. So the output type will basically come out as a dictionary if you wanted, or just kind of like a dictionary or a string or anything of that nature. And then we have a simple task. What are the best gold ETFs? What are the best American energy ETFs? And then we essentially just run this, and then we get the results. So it's pretty simple. You just fill this out like a little form, and then you get a list of tasks, and then everything is already handled like on the back end. So yeah. Yeah, so if we run this, we could see how it looks. Oh, I see. Just take that out. Run it again. Batch grid execution with 2 agents and number of tasks 2. So the number of agents and the number of tasks should be equal to each other. And gold ETF short-listed, US listed, physically backed, greater than or equal to US 1 billion AUM, expense ratio less than or greater than, less than or equal to 0.25, gold, iShares, SPDR, iShares Gold Trust. Energy sector, SPDR, XLE, Vanguard Energy ETF, iShares US Energy, Fidelity, and etc. So yeah, that's kind of an example of the batch grid workflow. So you could keep scaling this. The way that it works is it essentially leverages concurrent features. So essentially like the agents are executed in parallel with multiple cores. So yeah. Yeah, so essentially like the cores are executed in parallel, and it's super fast. So you could basically scale up with the number of CPU cores, and if you do that, then it'll be pretty fast. So. And so, yeah, that's the batch grid workflow. It's really good for when you have multiple tasks and you need multiple agents to do multiple things at the same time, essentially. So, yeah, and the documentation is also available at docs.swarms.world. So you could find it if you go here, batch grid workflow, and yeah, you essentially go and find these docs here. All you have to do is just type batch grid workflow in the search bar, and you should see it. So, yeah, so that's the batch grid workflow. It's actually very popular because you would want, like, this is really good for when you want agents to do multiple things at a single time. And we've just made it very simple. So, yeah, this is very beneficial. So moving on to the next entirely new features that we added is we added entirely new multi-agent runtime utilities. So you could now essentially run agents in parallel using UV loop, which is extremely fast, faster than Python's async framework. So yeah, you could run agents at the same time. You could run basically agents at the same time. We also have run agents with task UV loop, which provides coordinated task management across multiple agents. And we would actually recommend that if you're in a like high performance environment, you should probably use UV loop. So yeah, so this is like pretty interesting new runtime utility that we added, and I'll get out the examples. Just clean up this code. Yes, I'm gonna clean that up. All right, so let's get into it. So we just import some things here. Structs.agent, import agents. From swarms.structs, import multi-agent underscore exec. This file has a bunch of like multi-agent runtime utilities. So it has run agents with task UV loop, run agents concurrently UV loop, and yeah. So we basically import these things, and then we create the agents. Once we create the agents, then we have a task, and the task is write a 1 sentence summary. Actually, we could do something like write a creative story about sci-fi with no cliches. Very interesting to see how that would work. So result equal run agents concurrently .uv loop. This is a function, not a class. And here we do agents equals agents, and then task, and then yeah. And then we print the results. So we're going to run this. We're going to run 3 agents concurrently with UV loop. Max workers is 11 because it's dynamically calculated the number of CPU cores I have, which is, I think, 11. No, it's actually 12, but it's only fetching 90% of the CPU cores. So yeah, just to leave some space available. And so as you can see, the agents are running concurrently here. The echo of Solara. In the year 24th, humanity has outgrown Earth, but has not grown its walls. Colonies spread across the moon. That the most ambitious project lay in the depths of a crater on Mars Solara, a city built to harness the sun's energy in ways that defied physics itself. The structure was a marvel, a lattice of transparent solar panels embowed into new floor that glowed with a soft luminescence. Um, oh wow, it's an AI. A city of Allura floated above. Humanity had learned to listen to the universe, but had forgotten how to speak itself. This world was a tapestry of neon cities and sprawling megastructures, where the hum of drones drowned out the whispers of nature. People lived in the shadow of Ethereum. Ethereum. A colossal shimmering contract that floated above the earth, a remnant of an age where humanity believed it could harness the cosmos. Yeah, these stories seem pretty good. Um, but yeah, so you could, of course, customize the agents to do what you want. This is just an example for demonstration purposes. But yeah, so this is really good for when you want to do multiple things in parallel. You want to analyze different stocks in parallel. You want to have agent doctors in parallel, and etc. So yeah, this is very beneficial for when you want to do things in parallel. And so yeah, that's about it for the new runtime utilities. Um, we also made a vast array of improvements to hierarchical swarm with the streaming callback. We also improved majority voting, and we also improved the MCP uh, infrastructure as well. So I can go into majority voting now. So we're going to build an example, build a 3 quant. Cleaning up the folders. And we'll see just how much better the majority voting is in a couple of seconds here. Let me see if there's any questions.
Wow.
Hello, everyone. Hello, hello. Hello. All right, so we just had a cursor build us a couple of specialized prompts. These are all like quants agents. We don't need that anymore. Yeah, so we have 3 agents here. Technical analysis quant, fundamental analysis quant, risk management quant. And then, yeah, so going into the majority voting, you could fill this out in the following ways. So if it could have a name, so this is like quant analysis form. You could also give it a description. Let's see what else. Consensus agents. That should automatically appear. We have verbose, we have max loops. We also have the output settings. And we have the consensus agent prompt as well, which is another parameter that you can fill in. So yeah, basically it's much simpler now. The main majority voting structure The agents are going to run in parallel. So before they didn't run in parallel. So yeah, now the agents, when you run the majority voting, 3 agents are going to run in parallel. And then finally, an agent is going to summarize and aggregate all of these examples all at the same time. So that's essentially how the voting is conducted. An agent is an aggregator or a non-biased participant in summarizing the results of this voting procedure. There's a couple of ways, other ways you could do this. You could have the agents all vote, essentially given numerical outputs. For example, 1 or 2, 0 for no, 1 for yes. And you could do things like that. But that's relatively too simple to use for any type of, production grade system. So yeah, so we have 3 agents here. We're going to run this, and you'll see exactly how it works. So it's just getting started here. I'm going to once again remove that. You see, so all those agents, 3 agents just ran in parallel. And then one more agent's going to run, which is the like summarizer or aggregator. So, and yeah, that's about it. It's much simpler now. Before, it used to be extremely complicated. It used to always be like you had to give it a function, and that function would basically tell the agents how to basically it would essentially tell the like agent how to do the voting, which is not very efficient. So we just essentially cut that out, and we just made it much simpler and much easier to use. So, and it also runs in parallel now, so it's much faster. So yeah, that's new improvements to the majority voting. The hierarchical swarm has a new streaming callback function. So this is good for like production deployment of these multi-agent architectures. If you wanted to use this, for example, in an API server, and have it like stream in real time, this is probably what you would do. So, yeah, we can try and find this example. Yeah, we'll show a demonstration of this at a later time. And the MCP infrastructure. So if you would want to see essentially like what was the biggest changes, it's actually pretty simple. You go to MCP URL. Let's see. Yeah, so here, when you have an agent that you want to use MCP, basically what you do is you initialize your agents, and then here you have the parameters, and then here you have MCP URL, and then here you would change this out to SSE in the past, but now it's just you put the MCP URL /MCP. So it's much simpler. And then it could use the tools on that MCP server. So I'm not going to showcase this now because I'd have to set up an MCP server, and that would just take so much time. But yeah, so that's that. So in other updates, we also fixed a couple of issues, mostly within MCP. So we fixed MCP transports. we resolved the configuration and connection issues between SSE and streamable HTTP. So we also migrated the clients, and we also resolved some file path issues. So yeah, we didn't have too many issues, which is pretty good. So that was pretty nice. We do have some new docs and new examples. So we have new guides, multi MCP implementation. We have a new hierarchical workflow examples, and we have some new agent examples as well, such as the GeoGuessr agents and the Firecrawl agents integration. So I can show you exactly where those are. So if you go to our docs and you go to examples, you can see some of these agents. So here you have Firecrawl. This is where you can run the Firecrawl example. And we also have the MCP section as well. So you could do multi MCP integration, or just, oh, wow, gotta fix that. Agents with MCP, single agent with just MCP. But yeah, so we gotta fix that. And yeah, so then we have the other examples here, and then we have wow, that's strange. So the Nano Banana agent with Gemini Nano Banana, I'll show you those now. Where's we call it Jarvis. So we're going to copy that, put that there, and then we're going to put that image there too. So we're going to put that in the root. Then we're going to put the image. I'll show you how cool this is. This is crazy. So yeah, basically the way Nano Banana works is that you give it an image, and it'll basically output an image. So it'll output base64. And within this base64, you would basically give it an image, and it's going to generate a new image in a folder. So yeah, it's relatively simple to use, and you can edit images and or generate images. So yeah, I'll show you this now. This is the prompt that we're using, your location-based AR experience generator. Highlight points of interest in this image and annotate relevant information about it. Return the image only. And then so we're gonna have the agent here. We fill it out. This is the this is how you actually get Nano Banana. It's the model. It's Gemini Flash Image Preview is the official name. And then here we have some other settings that we can customize if we wanted. So, but yeah, we're gonna run this. Big bada boom, boom, boom. We could just clear this out to make it nicer. So we're going to process the image, then we're going to convert it to base64, which is how these models understand images. And then let's see what happened here. All right. Well, there might be some issues. Say, okay, so if we don't give it an image, we can do something interesting. So we say, generate an image of a funny looking kiwi with eyes, a mouth, and smile. So if you give it an image, if you give it a task and you say generate an image, it could generate an image if it works. So I think this might be an issue on my end, possibly pertaining to API keys, but we'll see. Yeah, this is interesting. This was working some time ago. What happened? All right. Well, we'll try and fix that soon enough. Let's try another example that we have here. This is the GeoGuessr agents. So yeah, this one works. Yeah, so the GeoGuessr basically just guesses, what location. Based on the visual cues in the image, I am highly confident this is Miami, Florida, which is true. That is Miami. Beautiful city. Yeah, but we can find the city just randomly. So we can go to, say, I don't know, mountain. Let's find some beautiful mountains. All right, let's see this one. All right, let's see if it can get this one correct. So we're gonna put in this image of mountains, and we'll see where it is. Where is this? Sagarmatha National Park. Very nice. Wow, I got it right. Most likely location: Everest region, Khumbu Valley, Nepal, with the prominent peak being Ama Dablam. The distinctive shape of the central mountain is almost unequivocally Ama Dablam. Sagarmatha National Park. Wow, I actually got it correct. That's pretty cool. Yeah, so the GeoGuessr works fine. The problem is generating an image. So I actually think it could be the prompts. Let's say generate the new image only. All right, let's see. I think the problem is the image generation capabilities. Yeah. All right. We'll have to take a look at that. But the GeoGuessr works completely fine, and it's actually extremely accurate. I don't know the complete limitations of the GeoGuessr, but seems to be really good. So yeah. Yeah, so we're gonna be putting out some more examples like this, GeoGuessr, Nano Banana, and cool applications that you could use to build custom agents. And yeah, so stay tuned on our Docs platform, docs.swarms.world, for any examples or any new guides and things of that nature. And so yeah, that basically concludes the updates. We have our next update coming in October 1st. So all of our release cycles are every 15 to 16 days. So every 15, 16 days, we'll release a new update and we'll share about it and share how it works. So if you'd like to stay updated, follow us on Twitter at swarms_corp, and follow us on GitHub as well. Start the repo, watch the repo, and you'll stay updated. So, yeah. Another important announcement is we're hiring. So we're hiring exceptional individuals to join our team, and accelerate the construction of the agent economy. We're recruiting agent engineers, researchers, full stack developers, and some non-developer positions such as video editors and more. So if you'd like to learn more, you can go to this link, swarms.ai/hiring, and you can learn more about Swarms and who we're looking for. So yeah. And in other wonderful news, we are going to be throwing the multi-agent hackathon pretty soon. So we're going to be throwing our hackathon in about next week. So next week, Saturday in San Francisco. So if you're in San Francisco, you should definitely come out. It's only been maybe two days, a day and a half or something. And we already have like 50 signups. So it's going to be incredible. It's going to be super fun. And yeah, we're going to ideally build the next generation of consumer apps, financial apps, natively powered by multi-agent systems. So I'm very excited to help support builders and building the apps of tomorrow today. And you should definitely check out our calendar, luma.swarms calendar. So, and you should also subscribe if you like to, get updates for our events in the future. So, yeah, thank you. Thanks for joining us for this all new Swarms updates. It's been incredibly fun, and yeah, we've been working very hard, and we're going to continue working very hard to build the world's best agentic infrastructure. So, thanks, and let's see if there's any questions. Hello, everyone. Sub. Crypto Word says good live. Thank you. Appreciate that. Let me check the comments on the phone. How's it going? You know what's crazy? We have grown to this point in Swarm's entire life cycle with only having 2 non-developers. This entire time, we have only had 2 non-developers on our team. We have a designer and we have a community manager. That's it. Which makes me very bullish because if we hire a pretty good marketing team, we could probably grow really fast. Given that Swarms technically is already, really, really reliable and really good. So we've been thinking about that, and we've been thinking about, how can we grow our marketing team and how can we do both marketing and having a great product at the same time and do that really well. If we do that really well, we'll definitively be number 1, without a doubt. No questions asked. So, yeah. So, yeah. If you'd like to find more resources, find our GitHub or our docs, here's some useful links. You can support us a lot by starting the GitHub, sharing the GitHub, contributing to the GitHub. That is, infinitely appreciated. And our website is swarms.ai if you'd like to learn more. Our docs is docs.swarms.world. Our Twitter is swarms_corp. And you can find our Discord link as well, which has over 14,000 builders in our website as well. So I'd recommend everyone to join our Discord and to participate in the discussions. So, yeah. And that's it. I'll probably share this presentation or the PDF below the live stream link. So if anybody wants it, you'll be able to get it there as well. So yeah. All right, everyone. Let me know if you have any questions. Um, all right, sounds good. All right, stay in tune for our next workshop and our next event next week in person in San Francisco. It's going to be super fun. If you're in the area, you should definitely think about coming. And yeah, thanks for coming to today's workshop and talk soon. Thank you.